So density of the object is 6 grams of objects. 6 grams per cm cube. Floats freely in a liquid of density. So density of liquid 8 grams per cm cube. Calculate the fraction of the solid that floats. Oh, there's the same question. Okay, that floats above the surface of the liquid. Okay, so this time around, we are looking for the fraction of the solid that floats above the surface of the liquid. Okay. From our previous questions, we're looking at the fraction submerged. But this time, the question is about the fraction of the solid that floats above the surface of the liquid. Okay. Now, once the question is about flotation, we are told the solid floats. So you state the condition for an object to float or to stay afloat, and that is mass of objects must be equal to mass of liquid displaced. And mass of objects coming. Okay. Mass of objects can be determined by density of objects times volume of objects. This is also equal to mass of liquid displaced can be density of liquid times volume of liquid. Please, are we okay?
Yes, please.
Okay. Now, look at, let's group densities at one side and then volume at the other side. So if we take a ratio of volume of liquid over volume of objects, this is equal to, we are taking a ratio of volume of liquid displaced over volume of objects. What will it be in terms of the density? Yes, help me out. Yes. What should the density be? Let's hurry up.
Density of liquid divided by density of object.
Okay, so I get you. So because our thought is to make VL on VO the subject, we first would have to divide through by VO. Okay, so VO, then we multiply through by 1 on rho of liquid. Okay, times 1 on rho of liquid. This and this will cancel out. So we have VL on VO is equal to rho O over rho L. Please, are we okay?
Yes, please.
Okay. And this fraction of volume of liquid displayed over volume of objects would be equal to fraction, okay, will be equal to fraction of objects submerged. So this, the ratio VL over VO is equal to fraction of object submerged, which is equal to rho naught over rho L. So all that we are saying is that if we are looking for the fraction of the object submerged in a liquid, which is VL over VO, it must be equal to rho O over rho L, which is density of the object divided by the density of the liquid. Please, is everything okay?
Yes.
Yeah.
Hello. Hello.
Please, I didn't get why.
Oh, go ahead with the
It's like-
question.
Why you multiply both sides by 11a. Sorry. Says one or L.
One on rho L. I did that because I'm looking for the ratio of volume of liquid displaced over the volume of the object. So it means I have to eliminate rho L, isn't it? If I want this, I have to eliminate this. And in eliminating this, you have to multiply both sides of the equation by 1 over rho L or divide through by this. That's why I've done that. Are you okay?
Yes, please. Say thank you.
Welcome. Any more questions? So what I'm saying is that the ratio volume of liquid displaced over volume of objects would give you fraction or is equal to fraction of objects submerged. And this is also equal to density of the object divided by the density of the liquid. Okay, so VL on V naught, which is actually equal to L fraction, is equal to what is the density of the object? It is 6 grams divided by the density of the liquid. Oh, no, it's rather, this is, okay, rho O over rho L. So density of the object is 6 divided by density of the liquid, which is 8. And this is equal to 3 on 4. So the fraction of the object submerged is equal to 3 on 4. Now the question is demanding that we find the fraction of the objects above. Is that okay?
Yes, please.
Good. We are to find the fraction of the object. Calculate the fraction of the solid that floats above. Now, fraction submerged plus fraction above must be equal to 1. Fraction amounts to 1. Okay, just as percentage also amount to 100. So the fraction of the object submerged plus the fraction of the object above must total 1. Okay, so if we have the fraction of the object submerged to be 3 on 4, what will be the fraction of the objects above? Yeah, do that for me. Calculate that for me.
One on 4.
So we have 1 minus fraction of the object submerged, and that is equal to 1 minus 3 on 4. And this will be 1 on 4. Therefore, fraction of objects above will be equal to 1 on 4 or 25%. Please, are we okay?
Yes,
So
Yes.
that's the solution to the question sent. If you have any question, quickly ask. If you don't have any, let's continue. Any question?
Yeah.
Hello.
Please, can we solve the first one? The one
First
before this. The one that the fraction submerged is 1/4.
I'm trying to. I don't have the question here. I'm trying to
And
get
I
the.
have the question.
Okay. Uh-huh.
A, a piece of wood of volume 40
So
centimeters cube.
so volume of wood is
40 centimeters cube.
40 cm cube. Uh-huh.
And density 0.5 grams per cubic meter.
Density of wood,
A
right?
cubic centimeter, sorry.
Density of
Yes,
wood, 0.
density wood 5 grams per cubic centimeter.
0.5 gram. Okay, perfect. Yeah. Uh-huh.
Floats in a liquid of density 2 grams per cubic centimeter.
So density of liquid 2 gram per cm cube. Mhm.
And then calculate the volume of wood submerged. Then
Volume
the fraction
of
of wood submerged.
wood submerged, and
Yeah.
fraction
Fraction
of
of wood
wood.
submerged.
Thank you. Good.
So thank you very much.
All right. Do I clean this side? What we've done? Do I clean it?
Yes, please.
All right. So I'm sure we were told from the question that the wood floats in the liquid. Do we have that information?
Yes, please.
Good. So once the wood floats in the liquid, okay, the law of flotation, mass of wood must be equal to mass of liquid displaced. Okay, now what is the mass of wood? Over here, we were given the volume of the wood and then the density of the wood. And so this can help us determine the mass of the wood. Okay, so mass of wood becomes 0.5 times 40 is equal to density of the liquid times volume of the liquid displaced. All right, so this is equal to 20 grams. Okay, 5 on 10 times 40 gives us 20 grams. Is equal to the density of the liquid is 2 grams times volume of liquid displaced. Now we are looking for the volume of the liquid displaced. So VL is equal to 10 cm cube. Volume of liquid display is equal to 10 cm cube. If volume of liquid display is equal to 10 cm cube, you see, the volume of liquid display is equal to that part of the object submerged in the liquid, because the volume of the object submerged would displace a certain volume of the liquid. And so volume of liquid display is equal to the volume of the object with submerged in the liquid. Okay, so therefore, volume of objects submerged is equal to 10 cm cubed. Therefore, we've even answered I. I says we have to calculate for the volume of wood submerged. And so that is equal to 10 cm cubed. Then I. Fraction of the wood submerged. Okay, the fraction of the wood submerged is equal to the volume of liquid displaced divided by the volume of the objects. Please don't forget this is also equal to rho O over rho L. But we won't consider this because we have the volume 1. Okay. Therefore, VL is 10 cm³ divided by the volume of the objects, okay, which is 40. We have 1 on 4, which is also equal to 25%. So from this, we can also deduce that fraction of the wood above would be equal to 75% or 75 on 100 or further. Please, are we okay? Are we okay?
Yes, please.
So that's simple. This, you see, this concept is used to calculate for the volume of ice cube, okay, submerged in water. You know, the only substance whose solid component floats in its liquid is water. The only substance whose solid would always float in its liquid is water. All other substances, the solid will submerge or will sink. When you take aluminum, solid aluminum will sink in a liquid aluminum. Solid gold will sink in liquid gold. But for water, the solid water would float on liquid water. That is why when you drop an ice cube in water, it is always on top of it. Now, when ice cube, whether small or big, is in water, we always have more than 80%, about 90% plus hidden or submerged in the water. That is why there is a popular proverb that what you see is just the tip of the iceberg. Okay, implying that what you see is just small. We have huge chunk down there. Okay, when you have an iceberg, we have more than 90% always submerged within the liquid. And so if you are to calculate for the volume of the ice submerged in the water, this is what you use. We have, because the ice floats, mass of ice must be equal to the mass of water displaced. So density of ice times volume of ice is equal to density of water times volume of water. Are you there? Class, are you there?
Yes, please.
All right. So we are looking for the volume of iceberg submerged. And so what we are going to do is that we are going to find a ratio of the volume of water to the volume of ice, because the volume of water displayed would give us the volume of the ice under the or submerged in the water. Okay, so we divide through by VI. This and this would be eliminated. Let me clean this part of it.
Mr. Dia,
Hello.
please, why did you get 75%?
Oh, the 75% refers to the fraction above the fraction of the object or solid above the surface of the liquid. Okay. Above. The 25 is below, submerged, but the 75 is above. Are you okay? So VW divided by VI is equal to, okay, since we have this, then we have to eliminate this 1 on rho W times 1 on rho W. This and this will cancel. This and this will cancel. So we have VW over VI will be equal to rho of I over rho of water. And this ratio is equal to fraction of ice submerged. That is equal to V on this. So fraction of ice submerged would be equal to density of ice over density of water. Now, density of ice is a little less than the density of water. And in one of the conditions for an object to float, we said the density of the object must be less than the density of the liquid. So if we have the density of ice to be slightly less than the density of water, then certainly ice will float on water. The density of ice is around 0.98 over the density of water is 1. Okay, meaning that if you have ice on water, always we have about 98% of it submerged. If you have ice on floating on water, we always have about 98% submerged. Only about 2% is what you see. Hence, the old adage that what you see is just the tip of the iceberg. Class, are you okay?
Yes, please.
Yes, please.
If you have watched Titanic before, this idea of the huge chunk of ice submerged is what caused the wreckage of the Titanic ship. How many of you have watched that movie before? Titanic. This volume of ice submerged thing is what caused the ship's wreckage, because the captain of the ship saw. Millicent, your hand is up. Hello, Millicent.
Sir, please, was a mistake.
Okay. The captain saw the iceberg, okay, at a distance, but he felt that because he had not done physics before, he felt that whatever he saw was just a small chunk of ice. And so he sailed, okay, around it or past it. And because ice always, okay, have this kind of characteristics, when he got close to it, there was this collision between the solid ice and then the ship. And so the impact, okay, broke the wooden or the metallic part of it, and water, I mean, filled the ship, and then got drowned. So if he had done physics, he wouldn't have, sailed near to the ship. Okay. All right. So that's it. If you have any question, ask. All right. If you don't have any question, then let's get into projectile motion. Projectile motion. What is a projectile motion or projectile motion? So two key terms to understand. What is a projectile? And what is projectile motion? Any idea? If you have any prior knowledge, you can share with us. The word to project means to throw. Okay, motions and vertical motion under gravity. We were using the term project. A body is projected from the surface of the ground from here. So the word to project in the context of physics means to throw. All right. Now, what do we mean by projectile motion? Projectile motion refers to the motion of an object or a body, okay, that is given an initial velocity. The motion of a body or an object that is given an initial velocity, and then the body falls under the influence of force of gravity, okay, in the absence of air resistance. I take it again. It refers to the motion of a body. Let me write something. So projectile motion So that's the definition. It refers to the motion of a body that is given an initial velocity and falls under the influence of gravity, force of gravity, neglecting air resistance. Okay, then what is a projectile? A projectile refers to the body. So, okay, I have this marker in my hand, when I throw it, the marker becomes the projectile. Its motion is what we are referring to as projectile motion. Please, are you okay? Hello, class.
Mr. Adria,
Hello.
Mr. Adria, so this projectile motion, it occurs when maybe you are in a room with closed windows and with closed windows, right?
I'll come there. Nice question. Okay. All right.